Good afternoon, fourth period. I need you to take out your homework. We're going to do a quick check. So I'm going to just pull this slowly down, and you need to get out a pen and mark it correct or circle it if you need to go back and revisit it. So number 1 is 27 times the square root of 19. Number 2 is 17 square root 21. Number 3 is 24 root 13 minus 4 root 7. You have different radicals, so you can't combine. Number 4 is negative square root of 2. You have to simplify the square root of 8 and then combine those. Number 5, root 18 simplifies to 3 root 2, and root 12 simplifies to 2 root 3, and that's your final answer. You can't combine those. Number 6, 27 root 7. Number 7 is 4 plus 6 root 3. There's nothing you can do to simplify that one. Number 8, 45 root 3 minus 3 root 5. Both of these, this one simplifies to the 45 root 3, and these two combine. Number 9 simplifies to 5 root 6. And number 10, when everything cancels out, it's just 0. So those are the answers. Circle those, and if you have questions, I can clear those up tomorrow. So let's look at what we're doing today. You need to have the note sheet. We're going to be talking about rational numbers and irrational numbers. So let's get started. Rational numbers and irrational numbers are part of what we call the real number system. And you probably know this left side. So we've got the smallest group is natural numbers, then whole numbers, then integers, then rationals. We use these most of the time in our equations. We just started introducing irrational. And irrational are numbers that continue without patterns. So let's give some examples. Natural numbers, write this on your notes. Natural numbers start at 1. So 1, 2, 3, and it's just like when you're a toddler and you start counting, you start with the natural numbers. Whole numbers include all the natural numbers plus 0. And I remember that because of the word whole. 0 plus 1, 2, and all the counting numbers. Integers, those include natural numbers, whole numbers, and then negative and positive counting numbers. So for example, you'll start maybe at -5, -4, -3, -2, -1, all the way up to positive numbers. So both negative and positive numbers that are whole numbers. Rational numbers are any numbers that can be written as a fraction, like a half, or 1/3. Now, if we see 1/3 as a decimal, we see it as 0.33 repeating. So any repeating decimals also are rationals, plus integers, plus whole numbers, plus natural numbers. So all this set, those are rational numbers. So what are irrational? They're the ones that act crazy. So if you think about the word irrational, your parents might have said, hey, you're acting irrationally today. That means crazy. So what does it mean for a number to be irrational? It means it doesn't have a pattern. It's acting crazy, like 3.1415 blah, and there's no pattern. You might recognize that. That is pi. Pi is an irrational number because it doesn't have a pattern. Other irrational numbers we've started working with this week. There's square roots that don't simplify. So like square root of 2, maybe square root of 5, maybe square root of 6. So any radical that doesn't simplify to a whole number is an irrational number. Okay, so let's look at the definitions. On your notes, you have these definitions with blanks where the blue words are. So I want you to fill it in. Okay, a rational number is one that can, C-A-N, can be represented as a ratio, P over Q. So it can be written as a fraction. So put in this, P over Q, such that P and Q are both integers, meaning that's not a decimal, they're integers, and Q cannot be 0 because you can't divide by 0. So you're going to fill in can, you're going to fill in integers, and you're going to fill in Q cannot be 0. Okay, the second part of that is all rational numbers can, so fill in can, be expressed as a terminating, T-E-R-M-I-N-A-T-I-N-G, terminating. That means one that stops, right? Or a repeating decimal. So let's talk about a terminating decimal. Here are some examples. And underneath, or on your notes, you've got some blanks. So let's fill them in. Okay, the first one is a terminating decimal, negative 0.5, which is negative 1/2. That terminates because it stops. Okay, it can also be a repeating decimal, like this one, 0.26 with a repeating sign. So that means it's 6, 6, 6, 6, 6, 6, right? It would keep going. So as long as it has a repeating decimal. Okay, other rational integers are 0. That's just like a number without a decimal or fraction. 7, 32. The square root of 4. Well, wait a minute. We thought we said square roots were irrational. But what do we know about the square root of 4? That simplifies to 2. So be careful, because just because you see a radical doesn't mean it's going to be irrational. If it simplifies, it might be rational. So any fractions also count. So maybe you'll see a half or 5/8. Those also are rationals. So now let's look at what an irrational number is. Irrational numbers, and again, you're going to fill in on your notes, any place you see these blue words. An irrational number is one that cannot be represented as a ratio of P to Q. Fill in P to Q. So we can't write it as a fraction, such that P and Q are both integers and Q is not 0. So we can't write it as a fraction. Okay, so irrational numbers cannot, fill that word in, cannot be expressed as a terminating or a repeating decimal. So it's the opposite of rational. So here's some examples. The first one is the square root of 3. The second one is pi. We know pi goes on forever. It never terminates. It never ends. And the square root of 52. We could simplify the square root of 52. It would simplify to 4 times 13. And then what do we know about that one? We can break 4 down to 2 and 2. We can simplify it by taking out a 2 from the radical, and we get 2 root 13. But since we still have a radical that cannot be simplified any further, that is still considered irrational. So if you don't trust me, take your calculator out, type in the square root of 3. You'll see that it is a pattern that's unending. You can do the same thing with the square root of 13. Put it in your calculator and you see this does not end. Okay, on the next page in your notes, or the next section of your notes, there's just a list of other examples. If you want to go through any of those, you can go through those if you're unsure on exactly what a rational and irrational is. That's just extra notes. Okay, so on this next part, we're going to try to decide which of the following numbers is rational and which one's irrational. And what I want you to do is just draw an arrow. If you think pi thirds is rational, you're going to put it over here. If you think it's irrational, just draw an arrow that way. So you're going to draw an arrow either left or right for each one of these. And there are 1, 2, 3, 4, 5 of these. And I'm going to give you 2 minutes to do that. Actually, I think I'm just going to give you 1. So let's take 1 minute and check that out. Thirty seconds. And you're getting to hear my dogs bark. And that's time. Okay, let's go up and check it. Okay, what do we think about the square root, or I'm sorry, pi over 3? Well, pi we know is irrational, and if we divide it by 3, it's still irrational. So that's an irrational number. 2. 2 is just a whole number, and it doesn't even have a decimal or a fraction, so that one's an easy one. That's just very simply a rational number. Square root of 3. Square root of 3 won't simplify, so it's a repeating, or it's a non-repeating, so it's going to be irrational. 1.76, that is what we call a terminating decimal, so it's irrational. Square root of 25. Don't let that tempt you to be irrational because it has a square root. That's actually rational. Why is that one rational? It's rational because that one simplifies just to 5, and 5 is indeed a rational number. The last one is 3/4. 3/4 can be written as a fraction, and it's also 0.75, which is a terminating decimal, so it is a rational number. Okay? So we can also do operations with rational and irrational numbers. So we're going to look at some examples. Can you add and subtract 2 rational numbers? So here's an example. Can we take 5.5 and add those together? Absolutely. We would just put a 1 under the 5, multiply the top and bottom by 2 to get a common denominator. That would give us 10 over 2 plus 1 over 2, and that would give us 11 over 2. So when we add 2 rational numbers, we get what kind of number? A rational number. So yes, we can add 2 rational numbers, and our answer is a rational number. And I'm just going to put rational here for our answer. Okay, so let's look at number 2. Can you add or subtract 2 irrational numbers? Well, the square root of 5 plus the square root of 7. We did this yesterday. Are those like terms? No. Can we add them together? No. So that is a no. We cannot add those 2 together. But could we add together 12 root 5, which is irrational, minus 7 root 5? Well, those are like terms. So we can combine those by adding or subtracting. In this case, we're subtracting. So 12 root 5 minus 7 root 5 is 5 root 5. So can we add or subtract rational numbers? And the answer is sometimes. The second one shows that we can sometimes add 2 rational numbers. Okay, third one. Can you add or subtract with 1 rational and 1 irrational? So can we take 7.5 or 7.5 and subtract like the square root of 10. No, you cannot combine those because they're not like terms. So a radical can only be added to another radical that has an identical value. So we can't add a rational and an irrational together. Okay, so we're going to stop here. I'm going to give you 5 minutes. You've got some rationals and irrationals, and I want to see if you can add and subtract those. So go. 5 minutes. Halfway, you have 2.5 minutes to finish up. If you're finished, you can help a neighbor. Okay, that was 5 minutes. So let's take a minute and check these over. Okay, let's look at number 1. We have 1/2 and 3/4. Those are two rational numbers. We can add fractions together very simply by multiplying the first equation or the first fraction by 2. That gives us 2/4 plus 3/4, and that gives us 5/4. So our answer is 5/4, and we're just adding two rational numbers, both being fractions. Now, we did this number 2. We have the square root of 9 minus 5. Now, you might have stopped and said, we can't do anything, but yes, you can. What do we know about the square root of 9? That one simplifies. So that's just going to be 3, because that's the square root of 9, minus 5, and the answer is -2. So can we take these two numbers, simplify this one to a rational? So that ended up being an irrational minus a rational. Okay, pi plus 8 pi. Well, we have to treat this just like there's a 1 here. What's 1 pi plus 8 pi? That's 9 pi. Now, what do we know? Irrational plus irrational adds to an irrational, and we could add those together because they're the same irrational number. Okay, let's look at number 4. We have the square root of 5 plus 4 square root 5 minus 8 square root 5. They're all irrational because they have radicals that won't simplify, but we can add those together because they're all the same radical. 1 plus 4 is 5 root 5. 5 root 5 minus 8 root 5 is -3 root 5. The answer is irrational. Okay, this one is 2 root 6 plus 5 root 24. You might think, nah, can't do that, can't add those together, but what do we know? We can simplify square root of 24. So I'm going to come down here, break 24 down into 2 times 12, which is 2 times 6, which is 2 times 3. We do a jailbreak, the 2 2's pair up, 1 comes out. So we have what's left. We have a 6 left. So if we bring out this 2 and we multiply it times 5, that term is going to be 10 root 6. So I'm simplifying 5, and I probably should have put the 5 here so I'd remember to multiply it. Okay, so that's going to be 10 root 6 plus 2 root 6. So the final answer is 12 root 6. So could we add together those rationals or irrationals? And the answer is yes, because they have the same radicals. Okay, let's look at this last one. Okay, we have a square root, and we have another square root, and then we have another square root. Do any of those simplify? And the answer is yes, all 3 of them simplify. So let's break each one down. 18, we break down to 2 times 9, and then 9 is 3 and 3. So we can jailbreak a 3, right? 3 times 4 is 12 square root. What's left? 2. Okay, what can we do with 16? Well, I hope you remember from yesterday when we made the list. That one's a perfect square, so that's 4. Minus, well, we need to simplify square root of 8. That's 2 times 4, and 4 is 2 times 2. So our prime factors are 2 times 2 times 2. Let's pair up. 1 escapes. So we have a 2 root 2. This one's left. So which can we add together? We can add these two irrational together. Actually, we're subtracting. So 12 root 2 minus 2 root 2 is 10 root 2. So the irrational portion is 10 root 2, and we have a real part of 4. So 4 plus 10 square root 2. Can we add the rational and the irrational? No, we can't add those together. Okay, so that's our first topic. So part of your homework is going to be deciding if we have rational and irrational numbers. So let's go back and look at our chart. Do we have a rational number? Do we have an irrational number? And can we do some basic operations, adding and subtracting, with those rational numbers and irrational numbers? The second topic we're going to talk about is how to divide by a radical. So we've got 3 scenarios here we're going to look at. We're going to look at how do you take a whole number and divide it by a radical? How do we take a radical and divide it by a radical? And then what if you have mixed? You have a whole number and a radical on top divided by a radical. So each scenario is slightly different, so you have to be careful you handle them correctly. So let's look at this first one. If you have 8 divided by root 2, we can write it like this with a division, but typically you're going to see it as a fraction, but they mean the same thing. Now, when you have a radical on the bottom, that's an irrational number in the denominator. And because it's irrational, we can't leave it down there. So what we're going to do is we're going to rationalize this fraction. So it's actually called rationalizing. So I'm going to take the denominator, and whatever the radical is, I'm going to multiply the bottom by the same radical. I'm also going to multiply the top by the same radical, because we know that anything over itself is 1. So what I'm doing is I'm multiplying by 1 in the form of whatever this bottom radical is over itself. Now, after I figure out what to multiply the top and bottom by, I then just multiply across. Well, on top, 8 times the square root of 2 is just going to be 8 square root of 2. You just put them next to each other because it's a product. The square root of 2 times the square root of 2, we learned this week, inside times inside, so that's going to be the square root of 4. Now, what we've just created is a perfect square. What do we know the square root of 4 is? That's just 2. So our denominator will now come out of a radical. The numerator, or the top, is 8 root 2. Now this one takes it one more step. We can now divide 8 by this whole number 2, because both of them are outside of the radical. So we can simplify that to 4 square root 2. And that's our final answer. Okay? So let's go back and review this one. What you want to do when you're dividing a whole number by a radical is multiply the top and bottom by that radical. You then multiply across, multiply across. The bottom, or the denominator, which is going to simplify to a nice pretty number, and then just reduce it if you can. Okay? And that's how you handle dividing by a whole number, or taking a whole number divided by a radical. Well, what if you have a radical divided by a radical? Well, you have a little slightly different set of rules. We have the square root of 15 divided by the square root of 3. Because 15 is divisible by 3 and they're both under the radical, we can divide those two numbers. So we can actually rewrite this with one big radical expression. Since they're both under the radical, we can write it like this. And we know 15 divided by 3 is just 5. So that's going to be the square root of 5. So all that is just going to simplify under the radical. The last kind is the kind that I call mixed, where we have whole numbers on the outside, coefficients, radicals divided by a radical. So this one we're going to handle similarly to this first one. Because we can't divide 2 into 3, you always want to check and see, can I divide my radicals? This one I can't. So I'm going to have to do what I did at the top. I'm going to have to multiply by the radical over itself. So this one, I have a radical of root 2. So I'm going to multiply the bottom and the top by the denominator. So whatever you have in the denominator, you want to multiply. Oops, that should be square root of 2. That value is just 1. Anything over itself is 1. So radical 2 over radical 2 is 1. Now we multiply across. 6 root 3 times root 2. Remember how we multiplied? Outside times outside, that's 6. Inside times inside, 3 times 2 is 6. So that's going to be 6 root 6. Now on the bottom, multiply inside times inside, root 4. But what did we learn earlier? Well, root 4 is perfect square, so it's 2. Oh, and on the bottom is 6 root 6 on top. Don't be tempted to stop there because we have 2 numbers outside the radical and we can reduce. So the final answer is 3 square root of 6. And that's how you rationalize the denominator. Okay, so let's practice a few of these. So this first one is a whole number divided by a radical. So which example is that like? That's like this first one. So let's work this one. We're going to have to multiply the top and bottom by the radical. So we're going to get 24 square root of 3. Whoops, that one jumped on me. 24 square roots of 3 all over the square root of 9. Well, what do we know about the square root of 9? That's 3 times 3, which is just 3. So each time you're going to get a perfect square on the bottom because you're multiplying by the same numbers. Then on top we have 24 root 3. Now can we reduce the coefficients? And we can. So the final answer is 24 divided by 3 is 8 square roots 3. So let's try this one. We have a radical on top and a radical on the bottom. So let's look at our example. What did we do with those? Well, we drew one big radical and we divided them if they can. So let's see. Let's draw one big radical. 39 divided by 3. Is 39 divisible by 3? And it is. It's going to be 13. So this just simplifies to the square root of 13. So those are very easy if these two numbers are both under the radical and they're both divisible. So just like when you multiply inside times inside, you can divide inside by inside. So let's look at this third one. We have a whole number with a radical. So we have a coefficient with a radical divided by a radical. Can we divide 10 by 7? Because they're both inside. And the answer is no. So we're going to have to go back and do what we did here. We're going to have to multiply by the radical. So let's multiply by root 7. When we do that, on the bottom, root 7 times root 7 is root 49. But we know that 7 times 7 jailbreak us 7. So that's on the bottom. But on top, we've got 4 times 1, so the outside is 4. Square root of 10 times the square root of 7 is the square root of 70. And that's what's on top. Well, square root of 70 does not simplify because the only factors are 7 times 10, and 10 is 2 times 5. And there are no pairs there. Therefore, we can't simplify that. So it ends up just being 4 times the square root of 70, all divided by 7, because the 4 and the 7 will not reduce. Okay? So, now it's your turn. I'm going to give you 2 minutes to work on these 3. If you can't do them, I at least want you to try. Do any of them. Compare them to the first set of problems that we did. And see, I'm trying to get the clock up here. Here we go. I'm going to give you 2 minutes to work on these and see if you can get any of them done. These do get to be a little tricky at first. So let's start the clock. 2 minutes, go. 1 minute. Okay, that was 2 minutes. Let's see if you got any of these done. Well, the first one, we had a radical divided by a radical. We can draw that as one big radical. So we have a 40 on top and a 10 on the bottom. Ask yourself, do those divide? And the answer is yes. 40 divided by 10 is 4. So we have the square root of 4. But we can take that one more step. What do we know about 4? It's a perfect square, and it's 2 times 2. So we can jailbreak the 2, and the answer is just 2. So that one was kind of nice and clean. But yes, you can divide radicals into radicals. Let's try the second one. We have a coefficient of 10 divided by root 6 and root 2. Now, let's look at the radicals. Can we divide 6 by 2? And the answer is yes. So this is very simply 10 root 3. We just divide 6 by 2 because they're both in the radical. Now this last one. It's slightly different than this one because we don't have the root 6. We have the whole number 10 without a radical, and we're dividing it by square root of 2. We can't divide those because 10 is not in the radical. So we're going to have to rationalize it by multiplying the top and the bottom by root 2. So let's multiply those together. Move this clock out of the way, timer out of the way. And that's going to give us 10 square roots of 2 on top, all over root 2 times root 2. That's root 4, inside times inside. Now, what do we know about the square root of 4? That's 2. So the 4 comes out of the radical as just a normal 2. We have a 10 root 2. Now you might be tempted to stop there, but don't forget, we now have outside and outside we can reduce. So 10 divided by 2 is 5 root 2. So you have several examples here of how to divide by a radical. So at this point, we are finished with the lesson. Yay! Okay, and I'm going to give you, or the sub's going to give you a little ticket out the door. You're going to have some time to work on this, and it's due before the end of class. When you turn it in, you're going to work on worksheet 8, which is your homework. So right now, your sub will give you the ticket out the door, and you will turn it in before you leave. Worksheet 8 is your homework. And while you're working, I'll play some music to work by.